tak dibenarkan menggunakan close braces. Walaupun tuan-tuan cakap ini fundamental golden rule in 𝐓𝐢𝐸. Ada golden rule.
No. As far as the Strata Management Act is concerned, there is no provision for any meeting.
Portion of the harta which belongs to the developer, there is a portion of property that belongs to on property belongs to her.
Sorry guys, I don't know.
It's like drink is already like what's that? Is that such a thing? So we will enforce 500
tak dibenarkan menggunakan close braces. Walaupun tuan-tuan cakap ini fundamental golden rule in 𝐓𝐸. Ada golden rule.
No. As far as the Strata Management Act is concerned, there is no provision for any meeting.
Portion of the harta which belongs to the developer, there is a portion of property that belongs to on property belongs to her.
A very good afternoon, ladies and gentlemen. Thank you for tuning in. Hope you are having a pleasant day. It's great to be back again this week with another episode of the Strata Talk Show. With that, I would like to welcome every one of you to the 58th episode of the Strata Talk Show, brought to you by the 𝐓𝐤𝐸 Academy of Real Estate. To our new viewers, in this talk show, we'll be discussing issues and cases related to the management of stratified developments with various industry professionals. Joining us today, we have Mr. Kuan, who is the Director of 𝐃𝐚𝐭𝐞 Building Solutions, to speak on the topic of advanced building inspection, linking relevant laws with forensic investigation. If you have any questions for Mr. Kuan, feel free to leave them in the Facebook comment section below, which will be addressed in the Q&A section at the end of the show. Without further ado, join me in welcoming Mr. Kuan 𝐤𝐸. Take it away, sir.
Hello, good afternoon, ladies and gentlemen. Thank you to 𝐓𝐤𝐸 Academy for inviting me again to give a talk on this webinar. So this time, furtherance to the topic that I have given, for instance, interflow leakage EM 1504 defect management. Now, actually, this advanced building surveying is more toward the latent defect investigation. So I would like to start my presentation now. Okay. Yeah, when it comes to building inspection, of course, we know that building condition survey or classic inspection, or whenever people got the new house owner or building owner got their vacant possession, then they will engage a building surveyor to conduct BP inspection to check their defects. Okay. Building inspection or building condition survey come in three protocols. The first protocol is visual inspection. Second protocol is non-destructive testing, and third protocol is destructive inspection. And I would like to show you the normal inspection that is normally carried out during the vacant possession. Is like using tapping rod to check the hollowness of tiles, using the spirit leveler to check the alignment of the door and the windows, to check if there is any gap, and using the mirror to check the bottom of the door. These are the typical thing that we do during the visual inspection for the vacant possession inspection. And I would like to come to the law pertaining to this inspection. In the sales and purchase agreement, the typical sales and purchase agreement, Schedule H for stratified building, Schedule G for landed building, and some other schedule for the special purpose arrangement. Well, during the effect liability period, the first 24 months, the house owner or the building owner are required to check the defect that become apparent. In layman term, is called patent defect, and report them to get it rectified within the 30 days according to the defect liability clause. So we are talking about defect that can be seen by naked eye. In this case, visual inspection is relevant. But after the defect liability period, if the defect that become apparent is not rectified or not identified, then the house owner forfeit the right to claim for the patent defect. However, it does not limit the right to claim for the defect that is not apparent or hidden. In layman term, is called latent defect. But there is something that we would like to share with you. In the event, even though during defect liability period, if some testing can be done to unveil the hidden defect, then the hidden defect become apparent. During DLP, we only require to identify. But after DLP, the implication is very different, which I will come to it shortly. Okay. Limitation Amendment Act have a special provision for latent defect. Latent defect, according to the Limitation Amendment Act 2018, it is hidden construction fault caused by negligence not involving personal injury with time bar of 15 years, starting from the date of action accrued, and 3 years limitation. So what do I mean by that? Indeed, I need to illustrate it with a timeline below. Okay. Say for instance, okay, if somebody, if A bought a house in the year 2000, in 2010, he discovered a crack, and this crack must be a structural concern. Okay, it is not something that is cosmetic. Okay, so this crack has been identified in 2010, and engineer has been engaged. The engineer say that the crack started to happen in 2002. So the date of action accrued is 2002, and the time gap is 8 years. So A can claim latent defect pertaining to this defect within 3 years. So before 2013, he must start legal action. Okay, but say A bought a new house or sub-sale house, and he discovered in 2020 another crack. Okay, and the engineer said that the crack happened in 2002. So with the time bar of 18 years, then he is not eligible to claim under Limitation Amendment Act. But this act has a weakness by itself because structure, for instance, are built to last 90 to 100 years. So it is still depend on the interpretation from the court later on because the act is so new. Okay, so let's see how the progress later on with some precedent later. Then I would like to come to what is the implication of Limitation Amendment Act. Since the word negligence is used, the law of tort all come in. In the law of tort, the aggrieved party have the burden of proof to prove the causation or the root cause, to prove the date and event of action accrued, and the proof standard of proof is balance of probability, whereby the judge feel more than 50% you are correct. And the format of report is based on Order 40A Rule 3 Rule of Court, which I will elaborate later. And the aggrieved party must suffer from damage, compromise in fitness for purpose, inconvenience, or some safety issue. Okay, For cosmetic damage that doesn't affect the fitness for purpose or compromise the quality of life, actually the aggrieved party or the claimant cannot claim, in fact. So lastly, whatever that started to become defective must not be caused by fair wear and tear, means the expiry of the typical service lifespan, vandalism, or poor maintenance. So we need to ascertain the root cause and need to make sure that everything is still within the typical service lifespan. And every different component in the building have their typical service lifespan. We can always check this out from the manufacturer for that particular component. Okay, next slide. So when it comes to who can testify, who can come in to become a witness to tell, okay, this happened in when, this, what was the date of action occurred and what was the event of action occurred. Well, according to Evidence Act, experts are specially skilled person. So when it comes to design, depending on engineering or architecture, so the relevant designer can testify. But when it comes to workmanship, we actually need the specialist tradesman. Just a very simple instance is, let's say, plumbing system. Perhaps we need a licensed plumber to come and check the workmanship. And for material failure, say for instance, plastic pipe, we do need someone like polymer scientist to come and verify. Okay. So the format for the report based on Order 40A Rule 3. The expert report shall have the detail of the expert pertaining to their qualification and experience, and then must have the detail of the literature or other material which the expert rely upon in making the report, and which must have a statement that he has considered what he ought to consider, and if applicable, if any test or the lab is engaged, then the tester and the lab detail need to be incorporated, especially when the use of tool. The tool must be calibrated, the person must be competent. Okay. And then where there is a range of opinion on the matter dealt with, then the expert need to summarize the range of opinion and give his reason for his summary, okay, for his opinion, and contain a summary of the conclusion reached, contain a statement of belief of correctness of the expert expert opinion, and contain a statement that the expert understand that by giving his opinion, he actually owe the duty to the court, not to the person who pay him, not to his customer. So this is something that need to be inside the report to be qualified as a expert report based on Evidence Act and the rule of court. And the most common type of defect, which is hidden, okay, is the leakage. And the landmark case is dual residency MC versus ADC, and crack 𝐾𝐚 versus 𝐕 and 𝐕. Okay, and why I need to come to this aspect of latent defect, because latent defect being intangible, we need to have special skill to either do testing or to scan or to open up to check, simply because it's hidden, So this is protocol 2 and protocol 3 in the first few slices that I mentioned, which I refer to as to be the advanced building inspection. Okay, so the typical checklist for the visual inspection, these are the typical checklists. I'm sure most of the building surveyor, they are aware of this. Okay, but this is the typical format based on the Royal Institute Surveyor Malaysia format, known as CP 101, CPBS 101. So giving mark to the condition of the situation, the urgency, and the the possible cause and the further action. So this format is actually based on JKR schedule, the JKR format, which is meant for maintenance purpose. So instead, I modified a bit in my type of report for latent defect investigation to have more space for the photo, because my type of report will have more photos, infrared image, and then as well as the testing, and as well as in this case, even the destructive inspection, by hacking and checking what is happening inside. And because the requirement to have the cost explained in detail and the suggestion when it comes to the rectification work, so there will be more elaboration in this part. And in my report, I will typically have a portion for conclusion and recommendation, which I will explain in further detail. What is the cause and what is the event that lead to all this type of latent defect. And based on Ministry of Housing actually recommend EN 1504, a European norm standard that is specifically meant for diagnosis, protection, repair, and rehabilitation of concrete structure. Non-destructive testing actually means the use of scientific equipment to unveil building defect through optical or laser, acoustic, radiological, or electromagnetic method, together with thermography and advanced tomography. This is okay, and I will go to that. What is meant by entity? Okay, the most common entity that I use, being an expert in leakage, in fact, infrared imaging have a number of inspection standard that is meant to identify dampness. Okay, so in fact, who is the competent or relevant expert when it comes to dampness? From my opinion, it is the certified infrared inspector. Okay, because infrared have a number of standard to detect water, simply because okay, and just for your information, I'm a competent person in infrared imaging. My tool has been calibrated, be it infrared drone or the handheld infrathermographic imager. Why we can check dampness easily with infrared? Simply because water can retain heat longer, and it need much more energy as compared to other type of material, which you can see from this table. To change every degree temperature, in order to increase or decrease, they need more energy. So in short, when they are heated, they need more time to cool down, and when they are cool, they need much more energy to be heated up. Okay, so by knowing the science behind it, there is infrared inspection standard for roof, for facade, for indoor. So these are the different standard for the inspection based on infrared. And diagrammatically, I would like to explain. Okay, let's say for the first diagram on the upper left. Okay, under the hot sun, waterproofing failure, area with waterproofing failure have one layer of water pocket under the surface. So under the hot sun, they absorb the same amount of solar energy as compared to the dry concrete. So wet concrete and dry concrete receive the same energy. But in the evening, the water pocket will remain hotter in the evening, and we are actually required to look for hot spot and verify with a moisture meter that can penetrate 20 mm from the surface. And for the inspection of facade, okay, because the water is very close to the surface, then it becomes hotter once it's exposed to the sun. So for facade, we also look for hotspot. But for indoor, because indoor the water is at the negative side of the wall, so it actually need longer time to be heated up, because the transfer of heat is at the from the positive side. So can always check it out with cold spot. So we do need to understand the size of water thermal capacity so that we can understand how it works. Okay, so these are the typical thing. Okay, the first photo on the left, upper left, these are what we see during in the evening for the roof inspection. And the other photo, okay, on the left at the bottom, these are the dam area with the blue spot. And for your information, the temperature of the dam spot actually keep on changing, and we do need to be cautious about when do we take the photo, you know. So at one point, somehow when everything is heated up, so the damp spot and the dry spot will be equally heated, you know. So in fact, for facade inspection, we do need to do it in the morning for the wall facing the east. And in the evening, we need to do it around 1 to 2 o'clock once it first exposed to the solar energy. And the one on the right bottom, these are the image that we can take from the inside of the house. Okay. So next, when we have identified abnormality with the heat distribution, then we need a moisture meter to confirm the dampness. Moisture meter harness the electric principle, whereby there is one side and not one side cathode. So when the two pins are or the multiple pins, okay, is attached to a surface with water. Water is a conductor, so the electric will be conducted and a reading will be given. And this two model of moisture meter, the one with two pins, is very useful for uneven surfaces. And the one with Tramax, the second moisture meter, actually have numerous pins, you know, and it is only suitable for flat surface because of the pins. And but for the second type, okay, let's talk about the pro and cons of different type of moisture meter. The first type of moisture meter also can be calibrated. Second type of moisture meter, both can be calibrated. But the first type with two pins, it depends on the force that we push in. The stronger we push in, the higher the contact surface, the more the contact surface become, and there will be more electric conducted. On the other hand, the second type doesn't need to depend on the force to push in, you know. So when it comes to the cord, the first type will be subject to a lot of attack because of the force to push in. So for the purpose of the cord, I always encourage inspector to use the second type. Okay, let's talk about how we can use infrared to detect pipe. For a hot water pipe that is poorly insulated, it can be detected so easily. Okay, just with infrared, I can see where is the location of the hot water pipe, as well as where is the leak, you know. And for cold water pipe, I cannot rely on the room temperature, so I need to pump in ice water into the pipe to create a big difference to the environment. So by pumping ice chill water into the pipe, then I can see the blue spot as per as the second spot below. And the infrared imager has been calibrated, and I'm a competent person for that. So even pipe can be seen by infrared imaging if you can understand how to create a big difference in the temperature as compared to the room temperature. Okay. And infrared imaging for instance, the first slide here, by capturing infrared images, I can know where is the abnormal surfaces, and by processing the images into three different color, the light gray, gray and dark gray, I can actually know where is the location of delaminated surface, soon to delaminate, as well as solid surfaces. So by processing infrared imaging, it can be achieved. So the next slide is about the inspection on the flat roof. This is actually a concrete roof with PU coating. Okay, but even though with PU coating, the PU coating actually crack and water seep into the surface to the concrete, and we can identify the water pocket. And by using my moisture meter, this moisture meter, Trimax moisture meter, the range is from 0 to 6.9. So 5.0 over 6.9 is considered highly damp, okay? High level of dampness. And another equipment that is very useful for investigation is bore scope. Bore scope can be very useful when it comes to confined space, so that we don't need to open up everything. Is in short, the peeping technology is very useful, for us as a building inspector for forensic engineering. And okay, for water tightness of domestic pipe, we can always do pressure gauge testing based on the SPAM testing and commissioning standard, or the ASTM water pressure gauge testing method. And even the gauge has been calibrated. Uh, Alternatively, you can also use a data logger like the prime log, which has been calibrated as well, to record different reading at the different intervals. So at the end of the day, we can plot out a graph to show if there is any drop in the water pressure, and it is very ideal for the presentation purpose. Okay. Acoustic leak detection. For leakage that is, let's say, hidden on the floor, first of all, we need to detect where is the position of the pipe which is embedded into the soil, okay, using ground penetrating radar. Then we can use data logger and acoustic leak detector to locate the leaking spot. And the way to do it is okay, this is a diagram, okay? So by moving the ground penetrating radar, we can locate where is the pipe, okay? So but after that, we put the sound logger into the different chamber to record the burst sound, and the software that isolate the noise interference can eventually detect the location of the leaking spot. At night, we go to the spot, at night, because with the least noise interference, then we use the huge stethoscope, where the doctor actually use the stethoscope to listen to our heart and our breathing, right? We in engineering, we also have huge type of stethoscope that can identify the burst sound up to 10-meter deep, So, and for leakage from the external wall as well as the window, there is another standard based on AAMA 511, Voluntary Guideline for Forensic Water Penetration Testing of Penetration Product. Okay, this nozzle, under the prescribed water pressure, it can spray out okay, water as if like the water is blown by wind at 30 meters per second. And bear in mind, Malaysia building has been designed to take wind loading of 30 meters per second. So the way I do the testing is spraying the water similar to 30 meters per second wind, blown by 30 meters per second wind, so that I don't overspray or underspray. So by sealing different component on the window, I actually can spray different component at one time and check one by one. So by doing so, I can know what is the leaking path, and I can do further testing, either by extracting sample, or if it is a sealant, or open up the window to check the built-in drainage or any any measure that can prevent water to enter. So this is a prescribed method based on empirical studies that is repeatable and and it's very reliable, and in fact I feel. So okay, and recently we also have this type of defect due to strong wind at the wind tunnel. And this wind tunnel is actually a voluntary study by the designer, okay, if allowed by the developer, then this study is very important to prevent all this type of suction. You see, this type of suction can pull down the ceiling as it is a very apparent defect, but it doesn't happen, on a daily basis. It only happens during very strong wind. And the way to verify this type of defect is by measuring the atmospheric pressure above the ceiling and below the ceiling during the strong wind. So you see a number of defects. We do need to have scientific explanation to tell the cause. And for this situation, we do need a barometer to measure the atmospheric pressure and the difference between atmospheric pressure above ceiling and below ceiling. Because if the pressure is big, whereby above ceiling is normal pressure, below ceiling due to the strong wind become very low in atmospheric pressure, then the normal pressure can push down the ceiling. And this type of thing, we do need innovative and we do need science and technology to prove our case, And in this case, my digital barometer has been calibrated as well. So premature paint failure is very common in new project as well. Okay, so it can be peeling, it can be blistering or cracking like this, and of course, the first thing we check if there is any moisture, because moisture can nullify warranty. So if there is no moisture and yet it failed due to the typical service lifespan, we can do chemical analysis using the MS2736 2022. We can do pull-off test, and we can even measure the thickness of the coating using the paint thickness meter. So nowadays, okay, I would like to explain a bit on MS2736. In MS2736, of course, the sample from the site will be collected. And the polymer scientists, after checking the type of paint, will normally require me to get, sample of good paint. Then they will use Fourier transform infrared technology to identify the performing ingredient and the quantity in using their technology. Okay, then they will compare it between the sample extracted from the site as well as sample that come with warranties, good samples, and to see the similarity thereof. And by having close similarity, then the material is within the tolerance to be good. If the similarity is too low, then the material fail. So we have different type of tests to do to prove our case nowadays. And even for concrete, okay, now we go to the heavier part. Heavier part now, concrete. Concrete, a number of studies actually reveal that abnormal crack in concrete always come from either misplaced, missing, or undersized reinforcement steel bar. And by doing concrete scanning, we can locate the position of the reinforcement steel bar, the diameter of the reinforcement steel bar, and even the type of the steel. And by having all this information, we can know is the rebar contributing to the loss of the specified strength. And to check compression strength, instead of coring, which is not recommended, we can do in situ testing using rebound hammer. The issue with rebound hammer is it always record higher reading than the actual, but the higher reading actually come from hitting on the area with reinforcement steel bar. So in order to prevent all this, we can use a metal detector to locate the position of the reinforcement steel bar. Then we hit our rebound hammer on the area without reinforcement steel bar. Then it will produce a much reliable record. Okay, and of course, a number of situation we understand that corrosion is the biggest threat to concrete. So corrosion is an electrochemical process whereby the corrosion risk can be measured using half cell method, half cell potential method, using a voltmeter to do assessment on the corrosion risk. So the diagram at the bottom right show how we present in our report the corrosion risk, the area with corrosion risk. Okay, so and carbonation is one of the key of concrete deterioration, uh, and it can be identified using phenolphthalein solution, whereby if the carbonation has entered into the concrete, it it will neutralize the concrete, and by neutralizing and bringing down the pH of concrete, when the concrete pH reach 9, corrosion will start on the reinforcement steel bar. So we actually need to know the depth of carbon dioxide penetration in order to understand has the infiltration of carbon dioxide gas or carbonic acid uh, triggered the corrosion. This can be done easily using phenolphthalein solution. Secondly, concrete health can also be done by assessing the pH of concrete. So pH 9 become a threshold because pH 9 is where the protective layer of the OH negative on the reinforcement steel bar is broken down and corrosion is triggered. Okay, and we also have the technology to ascertain how much chloride has penetrated into the concrete. So by doing a regression analysis, we can understand what is the remaining service lifespan of the concrete structure contaminated by chloride ion. So these are all the objectives that I mentioned. And cover meter testing can tell us the cover depth. Cover depth is actually the surface of the concrete, the distance between the surface of the concrete to the reinforcement steel bar. And this cover depth is very important when it comes to the durability of concrete. And normal concrete based on BS 8110 have 25 mm cover depth. And for liquid retaining structure, it has 40 mm. So this is a very useful meter, calibrated as well for checking the concrete cover. Because when we do inspection of the premature failure, we do need to check all the design parameter, and one of them is concrete cover. And next, ultrasonic pulse velocity based on ASTM C597-09 is very useful to measure the thickness of the slab, the condition of the crack propagation, as well as the identification of the object inside the concrete. So in this case, I actually did an inspection on a leaking swimming pool and I used ultrasonic pulse velocity to check the position and the availability of the water stock as well as the crack propagation. And let's say for groundwater. Groundwater, how do we scan the ground? Actually, we have electric resistivity tomography nowadays to scan the ground. And this one time of scanning around 80-meter length, and the depth can go to up to 15-meter deep. So we can understand the profile of the groundwater as well as the soil and the rock by doing this type of electric resistivity tomography. There are a few units in the industry now, and it can be done, okay, in Malaysia. So let me explain how all this NDT is used to unveil latent defect, okay, by illustrating it to you with a case study. In case one is about investigation of leaking of concealed pipe. Okay, concealed pipe, as you can as it indicate by itself, okay, as it's implied by itself, hidden. We don't know, it's all hidden, okay. But to check if there is any leaking, we can do a pressure gauge test, and the pressure gauge test show that at 10:45 a.m. the pressure was 2.75 bar, and in 7 minutes it dropped by 0.5 bar. So we can be sure that some leakage happened inside the wall, in the domestic pipe inside the wall, and the pressure gauge has been calibrated. Then I pump in the ice water so that I can cool down the pipe and see where is the leaking. From the inspection, okay, that you can see below, I discover there is a huge blue patch at the hand beaded tap. Okay. So I suspect there is a leaking spot. So I asked my worker to hack it out, and we discover, yes, there is a leakage. So in order to verify the workmanship, I get a licensed plumber in, and according to him, the workmanship is reasonably okay. So I send the sample to the lab, and the lab polymer scientist actually conducted a failure analysis, and she discovered that the material actually failed. So this is the typical type of thing that we need to do to unveil premature material and adhesive failure for hidden domestic pipe, which is a latent defect. Because the typical service lifespan of pipe is, based on rule of thumb, is 15 years. That's why having Limitation Amendment Act for the 15 years time bar is actually reasonable for most of the building component, which typically their lifespan doesn't exceed 15 years, except structure. Okay. And case 2, water seepage in basement. This is a basement in KL, okay, but I cannot reveal the name. So at the basement, I saw the leaking spot, and I mark it A, B, C, D. These are the 4 spots that I will keep on measuring the moisture level, and I conducted a dripping test. Coincidentally, above the leaking spot, there is a hydrant, So I asked the technician to open the hydrant slightly, and started to drip water. And coincidentally, it was a dry season. So after a few days, I go back and measure the moisture level, and I keep going back in different days, and I can plot a graph. Actually, on the 22nd of March, I discovered the moisture started to drop. So I went up to see the hydrant. Someone actually shut down my hydrant. So I open up the hydrant again, and I can observe an increase. And we are pretty safe to say that the leakage come from the surface water. But in order to isolate all the other possibility, I need to use infrared imaging and moisture meter to confirm the pipe is not leaking. I can even do a pressure gauge testing on the hydrant as well as the domestic pipe to confirm the domestic pipe and the hydrant pipe did not leak. Okay, but in the meantime, I also send the water sample to check the pH, chloride, ammonia, and E. coli, and I discover these parameters, they are all normals. So in short, we can conclude that okay, in fact, for some low rise, we actually can even dig out the soil to check what is underneath. Okay, so if I take the water sample to do X-ray fluorescence analysis, which analyze the water sample based on 84 minerals, I can get a water scientist and a geotechnic scientist to interpret my result and to understand what type of water is this. And if the budget is adequate, we can also even do electric resistivity tomography to see how the water actually came about under the soil, inside the soil. Okay. So in conclusion, it is a premature water proving failure. The building is less than 5 years old. Okay. From surface water, there's no leakage from the domestic and the waste pipe because the E. coli is the germs that we can find easily from wastewater. So the water sample doesn't even have any smell or E. coli. So it didn't come from the waste pipe. So this is how we come to a conclusion that this is a premature water proving failure, that the developer did not apply or construct it properly during the construction stage. Okay, let's go to case study 3. Delaminated surface on facade. Okay, delaminated surface, this is actually a real case. Okay, the cement street started to collapse and drop on the floor so badly, and it can endanger the residents who occupied the building. And how do we check delaminated surface? Look at this, the air. Air have very high thermal capacity. So under the hot sun, we can check the hot spot. Okay, this is my infrared drone. I capture infrared image using the infrared drone, and I process my image, and I can identify the location of delaminated or the area with risk of delamination and the solid surfaces. So meantime, we also erect scaffolding to extract sample to of good of the delaminated area and the solid area. We make comparison as well as we conduct water absorption and composition analysis. Okay, from beside we also did pull off tests based on BSEN 12504-3, and we discover the strength is bad, the adhesion is bad. Meantime, based on the Singapore standard and based on the advice from the lawyer, we need to quantify how many percent has actually delaminated. So we erected gondola and we tap on every meter square. Then we put on A4 paper, 2D diagram to map out where are the hollow location of a different hollow spot at different location. And the conclusion is premature adhesion failure because the building is also around 5 years old. Of the cement plaster on the external wall, the delaminated area and the area with risk of delamination is more than 40%. The reason is the absence of surface treatment on the base and the excessive thickness more than 25 mm. At some area which is thin, even though it cracked, it didn't delaminate. But area which is with thick cement plaster above 25 mm, even though without crack, it delaminated. So we can come to a conclusion that the delamination was caused by negligent. I think in this case is a poor QA/QC. Okay, that maybe wrong application method as well. That the absence of surface treatment and the excessive thickness are the causes that cause the delamination. So as you can see, these are the type of solid evidence that can tell the root cause that is so convincing. Okay, but we have to do a number of tests. And we like to come to a roof inspection in case 4. And in this roof inspection, we started doing it by using the ASTM C1153 standard by using infrared imaging. So I discovered the hotspot, as you can see in the first image on the left, upper left, and I go down to the one floor below. On the soffit, I also can identify the dampness using infrared imager. Then I confirm all the water pocket with a moisture meter. That gives me an idea of the leaking path, the relationship of the water pocket due to the water pouring failure to the presence of dampness in the parcels. Okay, but meantime, this roof with swimming pool also have a toilet for the changing room. So I need to make sure the toilet domestic pipe did not leak. So I did a pressure gauge test with a calibrated gauge. Meantime, I must also make sure that the swimming pool pipe penetration and underwater light fitting are not leaking as well. So I did a bucket test. The bucket test is, of course, by using a bucket filled up with water and put it inside to the pool. Of course, the water level in the water bucket is higher, so that the bucket doesn't float, freely. And then I mark the water level inside the bucket as well as outside the bucket, and I shut down all the valve, leave the bucket there for 24 hours. So after 24 hours, if I discover there's no significant difference between the water level inside the bucket and outside the bucket, then we can conclude that the pipe penetration as well as underwater light fitting are not leaking. Okay, we need to isolate or examine all the possible causes. Okay, then this is my doctor who helped me to extract the water pouring sample by removing the cement scrape. So look at the water pouring, the black color water pouring under the cement scrape. For your information, we were required to check 8 location, and out of the 8 location, 3 didn't even have the waterproofing layer. So we have discovered something so strong. Okay, the 5 locations that have waterproofing sample, we extracted the sample and sent to lab, put it under microscope and put it under MS2736. And bear in mind, MS2736 can also be used to verify the quality of waterproofing coating as well. No? So MS2736 is actually very useful for paint as well as waterproofing coating. Okay, I would like to share with you. This is the actual photo that we got in one of the sites. Okay, Tower A. The thickness of the waterproof is 0.15 mm, and the typical thickness of waterproofing coating of the same family is minimum 1.5 mm. So it only have 10% of the required thickness. Okay, and out of this 0.15 mm, 0.07 mm were the voids. Imagine in Tower 2, the void actually extended all the way down, making the very thin waterproofing membrane to become even thinner. So you see, so can you see, in terms of the evenness of the thickness, it also varies significantly. So the significant difference of the thickness is the implication of poor workmanship. And the thickness, such thin thickness, is an indicator of poor QA/QC. I have a reasonable ground to suspect the waterproof has been diluted, because without dilution, this type of bituminous compound cannot have bubbles, you see, and the voids were the bubbles. So, being a licensed applicator, I can testify on the workmanship, and my polymer scientist can testify on the material failure. So, the conclusion is, poor material. Similarity test based on MS2376 show that low similarity to good samples. Material fail, workmanship fail, this one. And then out of the 8 locations, 3 locations didn't even have waterproof. So I sure win this case. So these are the type of evidence that we need to tell the root cause for latent defect. Okay. And meantime, downstairs also have mold issue due to excessive dampness caused by the leakage. Okay. So in order to prove the damage, firstly, did the mold cause any ailment? If it did, then we need to know what type of mold or germs is that. Then we need to know what type of ailment that the residents suffer. As such, we do need expert in microbiology and medicine to help us to build up a case on this. But in general, relative humidity above 70% is known to be unhygienic. Okay. So for the concrete, when it is exposed to the dampness, especially in the presence of chloride, for instance, building close to the coastal area, as well as building with swimming pool. Okay, the chloride chloride is an accelerator that, or the catalyst that can accelerate the corrosion process. So firstly, we need to check the design parameter. This is actually a swimming pool. Okay, firstly, we check the design parameter, concrete cover depth using a cover meter. We also did rebound slammer to see the strength of the concrete. Okay, as well for the dry concrete as well as the delaminated or spore concrete. Then we also done carbonation tests to see how bad the infiltration of carbonate acid or carbon dioxide has gone into the concrete. We hack out a hole so that we can connect it to the half cell corrosion tool. But meantime, the hole has been used to measure the depth of the carbonation as well as the cover depth. Then we did UPV, ultrasonic pulse velocity, to check the water stop. Then, of course, we also did NT-build 443 to check the remaining service lifespan of the contaminated concrete. And in this case, the design parameter of liquid retaining structure, compression strength for the cube is 35, for the cone is 40 MPa. Concrete cover 40 mm, tolerance to crack 0.2 mm. Thickness of the wall for the swimming pool should be 300 mm. Type of concrete SAM3, water stop must be there. Designed to last 50 years. pH of concrete should be 12 to 13. At this type of pH, there shouldn't be any corrosion. Okay, and this is what we found out after all the tests. Compression strength is between 30 to 40 MPa. Concrete cover between 25 to 40. Crack width more than 0.2. Some of them are 0.3, 0.4, 0.5. Thickness of the wall 300 mm. Okay, but the type of concrete is SAM1. So the type of concrete have very big implication when it comes to the crack control as well as the density of the concrete. Water stop, there are water stop there. Carbonation started not long, so it is 10 mm to 20 mm. But the corrosion risk is very high based on the half cell corrosion mapping. pH of concrete between 8 to 10, we can see is deteriorating. The NT-build 443 actually told us the remaining lifespan of the contaminated swimming pool is left with 20 years only. Reinforcement steel bar, based on physical examination, there is minor peak corrosion, and the conclusion is the swimming pool was not constructed based on BS-𝐓𝐸𝐤𝐲07. BS-𝐓𝐸𝐲𝐲07 is design of concrete structure for retaining aqueous liquid. So with this type of tests, we know that we can conclude that the swimming pool has a big problem, and we need all this type of information to support our conclusion and to tell us the root cause of the leaking. And it also has very big implication when it comes to repair, because first of all, we need to restore the concrete performance as per BS-𝐓𝐸𝐲𝐸07. We need to control the corrosion because the corrosion risk is very high. Then only we waterproof. and it will cost a bomb, if we really have a swimming pool that is not designed based on the compliance with BS 8007. And yes, and this is a big implication, when it comes to the damage that you should be able to claim. So all this information, all this money that is spent on expert witness will be claimable based on claimable under special damage if you win the case. So I urge you to do more tests to have strong evidence that can justify your claim, and you can claim back all the expenses for litigation, for quantity survey, and for expert witness if you win the case. So this is the last slide of my presentation. I open to the floor for Q&A. Ince Mas.
All right. Thank you so much, Mr. Kuan, for that insightful talk. We have now reached the Q&A segment where you will hopefully clarify any questions they have on this topic.
I
All
think
right,
I took
starting
1
with the
hour
first question.
just in time.
Yep.
Yeah.
For the first question, it's going to be, how does the innovation and technology in the construction industry impact the built environment?
Okay, just to share with you something informal, okay? A lot of people used to think waterproofing can hardly be proven, Waterproofing failure can hardly be proven. Simply because it is embedded inside. It is inaccessible, unless you do hacking. And in the industry, building surveyor or architect engineer, they don't hack. They don't hack. And building, just for your information also, engineering student as well as architecture student, the time spent on waterproofing around 2 to 3 hours in most of the public university in Malaysia. 2 to 3 hours, what can you learn? So in short, they have very limited knowledge when it comes to waterproofing. But now with the technology, we can prove it very well. We can even prove with microscopic image, what is the profile of the waterproofing coating, what is the deterioration of the waterproofing based on similarity tests. And all this was not be able to achieve previously. Now it can be done. Because by having latent defect law, Limitation Amendment Act, we need to prove root cause. That's why we need to have more advanced building inspection method to unveil the root cause, to prove our case in the court. So I hope, and from my own observation in developed country, litigation has pushed the industry to become better, with better quality, less defect in long run. And this is my hope to help the end user or the aggrieved party to use litigation to improve the construction quality in future.
All right. Thank you, sir. Moving on, we have another question that reads, what are the top priorities of a building inspection?
Well, fitness for purpose. Of course, you're in the sales and purchase agreement. You are promised good material, workmanship according to approved drawing. You can find this clause in the construction quality. I think construction material and workmanship quality. There's such a standard clause in our sales and purchase agreement. But the implied term is fitness for purpose. The building not only must be good, it must be safe, it must be hygienic, it must be free from any nuisance when it comes to noise, when it comes to and compliance, and how to say, beside Besides complying to all the building codes, it must be reasonably comfortable and fit for purpose. That is very important, because yeah, wherever we check, the first thing is fitness for purpose. In fact, especially for latent defect investigation, whereby if there is any difference, okay, difference between the approved drawing and the actual situation, if you don't suffer from any damage, you actually cannot claim. So to prove that you suffer from any damage, actually the first thing that we check is fitness for purpose, So that's my answer.
All right, thank you, sir. Next would be, what are the top priorities of a building inspection?
I think I've explained this. This is a
Oh, sorry,
repetitive
sorry.
question.
Yeah, that was the previous one. Sorry about that. Right, next would be, what is the highest level of inspection?
What do you mean by highest level? Of course, the more comprehensive, the better. The first thing we check is the differences between the approved drawing and what you get at site. Okay. Second thing is we need to measure the alignment of your door, any hollowness, using some simple method. Okay, using spirit level, using tapping rod. Uh, but of course, even though during defect liability period, you can conduct flood tests, for instance. Uh, but of course, flood tests without a moisture meter, you don't know how to you cannot quantify the dampness. So we do need a moisture meter to help us to quantify. The more NDT you do, the safer you are. Especially when it comes to water pressure, you actually need a pressure gauge to measure. There's nothing that you can check by your naked eye, you see, when it comes to the water pressure. So the more tests, the better. Of course, the safer and the more beneficial for the end user lah. So when it comes to the highest level of inspection, when it comes to latent defect, of course, you need to be able to prove the root cause in such a solid and convincing manner. So the way that I explained just now with case study, I hope you can get this type of polymer scientist to tell us the waterproofing quality, licensed plumber to tell us about workmanship of plumbing, licensed applicator of waterproofing to tell us about waterproofing workmanship. These are the typical relevant things that one need to get in whole, so that you have a very strong and solid evidence.
Mm,
Yeah.
all right, thank you, Mr. Kuan. Lastly, we have a question from Mr. Majak, but I think this one, I can take this one. Right. So Mr. Bajaj asked if there is any recording for this session. Mr. Bajaj, you can watch the recording of this session on our Facebook page, our Excel Academy of Real Estate Facebook page. I repeat that, our Excel Academy of Real Estate Facebook page, as well as our YouTube channel, which would be Excel Academy on YouTube. I hope that answers your question. All right, we have now reached the end of this talk show. Once again, I would like to thank Mr. Kuan for his sharing today. There was a lot of insights, as well as our participants for tuning in. With that, I would like to end with inviting all of you to the Strata conference, Revitalizing Strata Communities, that's going to go on the 27th of July in Armada Hotel Petaling Jaya. If you are interested in joining, you may contact any of our sales rep down there, as well as visit our Facebook page and website, which is realestate.excelacademy.my. All right. Thanks again, Mr. Kwan. We hope to see you in
Thank
the
you very
next talk
much.
show.
Okay, thank you, everyone.
Thank you.
is already like what's that? Is there such a thing? So we will enforce. Why would we do that?
Tak dibenarkan menggunakan terus basic. Walaupun tuan-tuan cakap ini
fundamental golden rule in economic. And that golden rule
No. As far as the Strata Management Act is concerned, there is no provision for any meeting.
portion of the harta which belongs to the servant is a portion of property that belongs to own property belongs to her.
Sorry guys, I don't know siapa.
It's like 𝐓𝐢𝐸𝐤𝐞 is already like what's that? Is there such a thing? So we will enforce. Why would we do that?
tak dibenarkan menggunakan terus basic. Walaupun tuan-tuan cakap ini
Fundamental golden rule in economic. And that golden rule
No. As far as the Strata Management Act is concerned, there is no provision for any meeting.
portion of the harta which belongs to the servant is a portion of property that belongs to own property belongs to her.
Sorry guys, I don't know siapa.
It's like 𝐓𝐸𝐸𝐞 is already like what's that? Is there such a thing? So we will enforce. Why would we do that?
tak dibenarkan menggunakan terus basic. Walaupun tuan-tuan cakap ini
Fundamental golden rule in economic. And that golden rule
No. As far as the Strata Management Act is concerned, there is no provision for any meeting.
portion of the harta which belongs to the servant is a portion of property that belongs to own property belongs to her.
Sorry guys, I don't know siapa.
It's like 𝐓𝐸𝐸𝐞 is already like what's that? Is there such a thing? So we will enforce. Why would we do that?
tak dibenarkan menggunakan terus basic. Walaupun tuan-tuan cakap ini
Fundamental golden rule in economic. And that golden rule
No. As far as the Strata Management Act is concerned, there is no provision for any meeting.
portion of the harta which belongs to the servant is a portion of property that belongs to own property